Let's talk about another example of trigonometric identities. So as you can see, my example is prove that secant theta minus cosine theta over secant theta plus cosine theta is equal to sine square theta over 1 plus cosine square theta. So as you remember, I always take my left hand side to start with. So I'm going to consider my left hand side, and as you can see, my left hand side is secant theta minus cosine theta over secant theta plus cosine theta. Just to remind you that whenever I solve a problem related to trigonometric identities, what I do, I try to convert everything in sine, cosine and tangent. So basically, if I have any trigonometric ratio that is basically cosecant, secant or cotangent, I try to convert into sine, cosine or tangent. So as you can see over here, I have trigonometric ratio given as secant theta. So instead of writing a secant theta, I would like to convert into something like a sine, cosine or tangent. So wait a minute. I know that secant theta is 1 over cosine theta because secant is reciprocal of cosine. So I can easily write secant as 1 over cosine. So now what I'm going to do, I'm going to substitute secant by 1 over cosine. So let's do that, and if I do that, I will write 1 over cosine for this secant minus cosine theta over this secant is again 1 over cosine, so I write 1 over cosine theta plus this plus sine, I have a cosine theta. Now, if you look closely, you will see I have this expression. So basically I had cosine and I wrote cosine over 1 because anything divided by 1 is basically the same thing. So now my expression is 1 over cosine minus cosine theta over 1 over 1 over cosine plus cosine theta over 1. Now I can easily subtract and add numerator and denominator separately, because like as you can see, numerator and denominator, they have two different expressions. So basically what I want to do, I want to make sure that the numerator expression has same denominator. So if you look closely, I have cosine theta right here and I have 1 over here. How do I make the common denominator? The easiest way I can think of, multiplying numerator and denominator by cosine theta, right? So I will do the same thing with the denominator term. So I'm going to multiply numerator and denominator by cosine, right? Pretty simple, huh? Now let's keep going. So what I'm going to do, I'm going to write here as this is equal to 1 over cosine. So this is the numerator term, 1 over cosine theta minus cosine times cosine is cosine square theta over 1 times cosine is cosine. In the same way, my denominator term is 1 over cosine theta plus cosine times cosine is cosine squared over 1 times cosine is cosine theta. Now, if you look at the numerator, like right here, you will see my denominator for the numerator expression is same, both have cosine. So I can easily subtract. And the same thing is true for the term for the denominator. Look at this, I have cosine at the denominator for the denominator term or the expression, right? So what I'm going to do, I'm going to simply subtract and add, and if I do that, I will write this denominator symbol. Now I have 1 minus cosine squared theta over divided by cosine theta. So this is my numerator term, and my denominator is 1 plus cosine square theta over cosine theta. Now, what I'm basically doing, I'm simplifying numerator and denominator separate, right? Now, this is basically what? Numerator divided by denominator. So I'm going to write this one as 1 minus cosine square theta over cosine theta divided by 1 plus cosine square theta divided by cosine theta. This is what this whole expression, the one that you have over here, means. Now, the inverse of division is multiplication. So, if I want to convert this division basically into multiplication, I need to flip this expression because then it will be a multiplication. So, I'm going to simplify this and I will write 1 minus cosine square theta over cosine theta times, I'm going to flip it and I will write cosine theta over 1 plus cosine square theta. Now, as you can see, now I can cancel out the equal terms. So I have cosine here will be cancelled out by cosine. So if I cancel this out, I have 1 minus cosine square theta over 1, because this cosine is cancelled out, so I have only thing left is 1, times 1, over here 1 is left, over 1 plus cosine square theta. Now 1 minus cosine square theta times 1 is 1 minus cosine square theta, and 1 times 1 plus cosine square theta is 1 plus cosine square theta. And we all know that 1 minus cosine square theta is basically what? Sine square theta over 1 plus cosine square theta. And this is my what? Right hand side. Look at this. This is my right hand side from here. So basically what I did, I started with left hand side and I proved that left hand side can be converted into right hand side, right? So basically we proved that left hand side is equal to right hand side for this example. So this is how we will prove for any trigonometric identity from starting with left hand side, I should say starting with left hand side, taking the left hand side and converting that left hand side to the right hand side. So in that way left hand side is equal to right hand side, and basically we can say that hence proved, because we proved that left hand side is equal to right hand side.